matter around us pure. So in the first session we have seen that matter in our surroundings lesson. We have seen the definition for matter. So what's the definition we have seen? Can you recall it? Anything which occupies some space and having some mass, we may define it as matter. Okay. So what is the anything? Anything might be a physical object. The physical object which may be in the form of solid, liquid or gas. So actually anything that is in the form of solid. Okay, the food we have taken and the chalk paste, the bow, the duster, even the stones, bricks, everything is made up of a physical object which is in the form of solid. And the liquid we drink and anything which is in the liquid form definitely is having some space and occupies some mass. And air we breathe, in all the components of air, all are having some mass and are having some space. So anything which occupies some space and having some mass, we may define it as matter. Okay. So the next term we have seen is pure. Actually, what is pure? When we say any substance is pure, definitely it doesn't contain any adulteration in it. Okay. We cannot mix anything into that. We may say that the substance is said to be in the form of pure. But we have two things. One from our point of view, other from the scientist's point of view. From our point of view, when we take milk, the milk contains uniform, it is to be completely milk, which is in a form, which is in a color of white. If I won't mix anything into that, we may say the substance in the form of pure. That is, there is no adulteration in it. From my point of view, I consider that milk is in the form of pure. But from the point of scientist, he must consider that milk is not a pure substance. From their point of view, if they take any substances, the substance is made up of only one kind of particles. That is either to be atoms or particles, but it is made up of only one kind of particles. Okay. For milk, they have proteins, fats, and sugar. So it contains all these compounds as mixed together. That is containing more than one kind of particles. So they won't consider that substance in the form of pure. Okay. And if I had given you soil and I had given you sugar granules or salt granules, okay, I find out to find which one is in the form of pure. You may say, by seeing we have seen clearly salt or sugar granules in the pure form and the soil is not in the pure form. It is in the form of mixtures because in the soil it contains small fine granules of salt stones, even the humus particles and even the dead organisms. Everything is present together, that is containing more than one kind of particles. We won't say that soil is in the form of pure. Okay, so based on that, we are going to discuss the matter and its classifications. Okay, so what is matter? Which is in the form of solid, liquid or gas, having space and having some mass. So we may classify the matter into two things. One is we may call it as pure substances and other we call it as mixtures. The pure substances, we know it is made up of only one kind of particles. This pure substance is again classified into two forms. One is element and another one is to be compound. And we come for mixtures, we have two things. One is called as homogeneous mixture and another is called as heterogeneous mixture. Okay, so in this class we are going to discuss about only the pure substances, elements and compounds and its properties. In the next session we are going to discuss about the mixtures and the homogeneous nature and its heterogeneous nature. Okay, and now we are going to discuss about the pure substances. You may copy to this in your class. Next, we are going to discuss about pure substances. So, what's the definition we have seen for pure substances? Anything, any object which is in the pure form of pure, definitely it is made up of only one kind of particles. That particles might be either atoms or molecules. Okay, that's the definition we have seen for pure substances. So, I had given you two examples here. One is sulfur and another one is to be water molecules. When I have taken sulfur element, this sulfur is made up of only one kind of particles of sulfur alone, sulfur atom alone. If I take water molecule is also made up of only one kind of particles. When we have taken hydrogen and oxygen, these hydrogen and oxygen has combined together to form a water molecule. But water molecule is made up of only one kind of particles of H2O. So this one particle is When we say as a pure substances, definitely it is having that is a fixed composition. If I have to prepare water, that water contains hydrogen and oxygen. So it is always in a ratio of 2:1. So wherever I have prepared, in whatever method I have prepared, it is always in a ratio of 2:1. We know it. Okay. So whenever we say a substance which is in a state of pure form, definitely it is having some fixed composition. If I have to prepare copper sulfate or sodium chloride or calcium oxide, whatever pure substance I have prepared, it is always having some fixed composition. In that composition only we can able to prepare the certain substances. Okay, and we cannot able to separate those substances by physical method. Okay, by electrical method, otherwise by chemical method alone we can able to separate the pure substances. If I take water, we know water contains hydrogen and as well as oxygen. Okay, but this hydrogen and oxygen cannot be separated by any of the physical process, by any of the physical methods. We know some of the physical methods, either the evaporation, centrifugation, by being separated from filtration, decantation. We know different types of physical methods, but those methods cannot be adapted to separate the pure substances. It can be able to separate only by chemical process. Okay, and if I need to prepare water, I have to add hydrogen and oxygen, and this hydrogen and oxygen cannot be separated by any of the physical process. We may use electric method, that is the electrical decomposition method only. We can able to separate out the hydrogen and oxygen. So pure substances cannot be separated by physical process, otherwise by physical method. And it is having some fixed composition. It always present in a fixed composition, and physical substances or pure substances having some fixed melting point, and as well as they are having some fixed boiling point. One of the substances having fixed composition, there is no adaptation in that. Definitely those substances are having some fixed melting point and as well as having some fixed boiling point. If I take water, its melting point is 0 degrees Celsius. Its boiling point is 100 degrees Celsius. If I have mixed anything into that water, its melting point and boiling point may vary. But if I doesn't mix anything into that, its melting point shows it to be 100 degrees, 0 degrees Celsius wherever I have built, and its boiling point is said to be as 100 degrees Celsius wherever I boil. So if I have mixed anything, the way of melting and boiling may change. But in case if it is in the form of pure, definitely it is having a fixed melting point and as well as having some fixed boiling point. So what are the definitions? Please still now we have seen about the pure substances. Pure substance is made up of only one kind of particles, that is to be either atoms or molecules. So and we cannot able to separate out the pure substances by any of the physical method. It is having some fixed composition and it is having some fixed melting point and as well as boiling point. Next we are going to discuss about elements. Okay, elements. So how the pure substance is classified? We know that the pure substance is classified into two parts. One is element and the other one is to be compound. So actually what is an element is, we know from the lower class onwards, a substance which cannot be able to split further. That is, we cannot be able to split into two or more substances. We call it as elements. So elements cannot be split up into two or more simple substances. So we cannot be able to split the elements further and further. Once given these small atoms, so that atoms cannot be able to split further. That is, it is made up of only one kind of atoms. If I take So elements we know that should be classified as metals, non-metals and metalloids, you know. So based on the properties we may classify it as metals and non-metals and metalloids. We have some properties which has to define us whether the substance is metal or non-metal, okay, or metalloids. So what are the properties? We know metals are mostly hard in nature. So most of the metals are hard in nature. It is present in the form as the form of mostly hard. And we have some other metals which is also to be soft in nature, that is sodium and potassium. These two metals we may even cut with a knife also. So those two metals are soft. Apart from that, all the metals has to be hard in nature. And we have two more metals, that is cesium and gallium. Even those metals we may keep it in our form. It has to melt at our own temperature. So these metals may in the form of liquid at room temperature. And the mercury, we know that is the only metal which exists in the form of liquid. So metals are hard in nature. Mostly all the metals are hard in nature except some metals. Sodium and potassium is to be soft metal, and mercury which is in the form of liquid, and we know that cesium and gallium even melts at the room temperature, okay, by the heat of our power. And the metals are mostly exist in a variety of colors. That is not variety of colors, it shows us that this shows mostly greyish color or else to be yellowish. You see the gold, you know, the gold is in the form of yellow color, and silver or iron or aluminum is in the form of greyish silver color. So most of the metals either in the form of greyish form or otherwise in the form of yellow. Okay, and we know that most of the metals are lustrous in nature. That is what is lustrous? It shows some shiny appearance, you know. It is called as lustrous. So most of the metals are lustrous in nature. So metals are hard in nature and it has been available in different colors, and as well as it shows lustrous appearance, and it has the property of malleability. So what is malleability? We can able to beat the metal into thin sheets. That property we call it as malleability. So metals has the capability of forming a malleable nature due to that we can change into thin sheets. Okay. The next property we have is ductility. So what is ductility? By beating the metal, we can change into a thin wire. We may call this process as ductility. So metals has the process capability of having ductile nature. And the next one is sonorous. So what is sonorous? A metal on striking, it produces ringing sound. So we may call metal as nature of sonority because these metals have the nature to produce the ringing sound. So metals are sonorous in nature. And we know that metals are good conductors of heat and as well as electricity. Most of the metals are good conductors. Almost all the metals are good conductors of electricity and as well as heat. Okay. And these are the properties we have seen. What is the first one? Is hard in nature, then it should be lustrous in nature, and malleability, ductility, sonority, and good conductors of heat and electricity. So let me come for the non-metals. So what is about non-metals? We say that metals are hard in nature, you know, but when we come for the non-metals, we have most of the non-metals are powder in form, and as well as they should be not hard as such metals. Okay, and some of the non-metals are in the form of gaseous form. And we have one non-metal which is also in the form of liquid, is bromine. We have the metal which is in the form of liquid, you know, that is called as mercury. Just like that, for non-metal also we have bromine is the non-metal which is in the form of liquid. Okay, and it also does it have the due to this property? It doesn't have the property of having malleability and ductility and sonority. So it doesn't have malleable nature, ductile nature, and sonorous in nature. And most of the non-metals are poor conductors of heat and electricity, except graphite. Okay, graphite is one of the carbon non-metal, form of carbon non-metal, and it has a capability of conducting electricity. Okay, and these non-metals are available in variety of colors. Okay, and this is lustrous, you know, lustrous for non-metal, graphite and iodine. These graphite and iodine having some lustrous in nature when compared to other non-metals in the elements, in the periodic table. Okay, contains only one kind of element, that is atoms. Okay, that is the definition we have seen for element. For compounds, it is made up of more than one kind of elements. That is two or different kinds of atoms chemically combined together in a fixed proportion by mass. We may call it as compounds. That is called as it has chemically combined in a fixed proportion by mass. If I need to prepare a water molecule, so what I have to do? I need hydrogen and as well as oxygen. In whatever method I have prepared, it is always in a mass of 1:8. Wherever I have prepared, in whatever method I have prepared, this water molecule is always in a ratio of 1:8. Okay, so and these compounds cannot be separated by any of the physical methods. By using the chemical method alone, we can able to separate out the compounds by the physical method, such as separating phenol or filtration or evaporation or crystallization. In any of the methods, we cannot able to separate out these compounds. Okay, and if I come for another example for iron sulfide. Iron sulfide contain iron filings and as well as sulfur powder. If I need to separate these iron filings and sulfur powder, what I have to do? I will use magnet. I am using magnet to separate out the iron filings from that. For sulfur powder, I have to use carbon disulfide. Okay, so I have used the carbon disulfide, dissolve the sulfur powder, and I have separated out the sulfur from the iron sulfide. This is the physical method. But what I have to do? I just heat this iron sulfide, iron and sulfur, and get a black powder of iron sulfide. If it is possible for me to separate out the iron and sulfur from the black powder, no, I can't, because these iron and sulfur has mixed together and they are chemically combined from a new product as iron sulfide. So these iron sulfide cannot be able to separate out. It is to be homogeneous, it is to be uniform throughout. So I cannot able to separate out the iron filings and the sulfur powder from the mixture. So these compounds are chemically combined together and having some fixed proportions. So you cannot able to separate out the compounds by any of the physical method. And iron cannot be separated by magnet and sulfur cannot be separated by carbon disulfide. Even it forms a compound of black colored compound of iron sulfide. Okay. So what's the definition we have seen? Made up of two or more elements chemically combined in a fixed proportion by mass. We may define it as compound. So it is always having some fixed proportions. We cannot able to separate out by any of the physical methods. Even we have taken iron filings. The iron filings also cannot be, that is iron filings and sulfur, and it forms a product of iron sulfide that cannot also be that is separated by any of the physical methods. Okay. And next we are going to see about the remaining properties. The next property is the properties of a compound are entirely different from those of its constant elements. What I told you, I have prepared iron sulfide, you know. What I have taken iron and sulfur. On heating, what I have prepared? Iron sulfide, a black color compound. So is the nature of iron sulfide a black color compound has the same property of what I have taken as iron and sulfur? Even I have taken the iron sulfide cannot be able to separate with any physical methods. You know, I cannot able to use any magnet to separate out the iron, and I cannot able to use carbon disulfide to separate out the sulfur. But it has a completely homogeneous in nature. So its nature is to be quite entirely different when the compound is being formed. Even I have taken water. That water in the form of liquid. But what I have taken to prepare water, I need hydrogen and as well as oxygen. Those hydrogen and oxygen in the form of gas. It is to be chemically combined together. It produces a water molecule. So its nature is to be quite different. Its nature is to be also be quite different when compared to the original form. So its nature, these compounds are entirely different from those of its constituent elements. When the compound is being chemically formed, its constituent nature is quite different from those of the elements. So I have prepared iron sulfide. It is in the ratio of 7:4, and it is being chemically prepared. It is called as there is a chemical change occurred during the preparation of an iron compound. So when we have say a chemical changes occur when the reaction takes place between two elements, otherwise between two substances, then the chemical reaction mass. So whatever compounds we may prepare, it always contains some fixed proportion, and even we have doesn't mix anything into that, definitely it is having some fixed melting point and as well as some fixed boiling point. And when we say it is a compound, definitely it is to be homogeneous in nature. That is, homogeneous means that it is to be completely uniform throughout the solution. We are not able to alter the solution at all. So we may say that it is to be homogeneous in nature. So compounds are two or more elements that is chemically combined in a fixed proportion by mass. It is, whenever the compounds form, it is to be of chemical change, and it is to be entirely different from the constituent elements when the compound is being formed and having some fixed proportion by mass, and having it is to be homogeneous in nature and having fixed melting point and boiling point. So in this class we have discussed about a definition for matter, and we have seen the properties of pure substances, and we have seen the definition for element, and we may classify the elements into three parts. One is called as metals, non-metals and metalloids, and we have seen the properties of compounds. In the next class we are going to discuss